9x.
Good. I would definitely agree with that. So you can't just divide by 2. But why would you want to divide by 2 in the first place? What makes this different to what we've seen before?
It's because the x squared has a number next to it.
Because we've got that number sitting there in front of the x squared, okay? Now, before, when we were dealing with stuff like this, so x squared plus 3x plus 2, for example, there was a number there, but what was that number?
1.
It was a 1, right? And in English, when we say something starts with a 1, or when we're talking about ones, does anybody know what we tend to call that? We tend to call it monic, okay? So if you think about the word mono, it means 1. Okay, monotonous means you're talking one like tone all the time. Great. So what would this one be? Because it starts with a 2, it's not a 1, therefore it's a non-monic. Okay. Now I'm introducing this language to you because I will use it. Okay, I will use it. So if I say to you a monic quadratic, I mean something like this. If I say a non-monic quadratic, I mean the number in front of the x squared is not a 1. Interestingly, would this be a monic quadratic?
No.
Why not?
Negative 1.
Exactly, it starts with a negative 1 instead. So this one would be non-monic. Okay, this one's non-monic. So basically, if it starts with a 1, it's monic. If it doesn't, it's non-monic. Is that clear? Okay. So that's what's making this awkward. It's the number in front of the x squared. It's not a 1 anymore. So we need to come up with a new way of dealing with it. Now just remind me, when we were dealing with things like this, we were looking for 2 numbers that multiply together to make something and add together to make something. So look at that top one. What 2 numbers would you be looking to add, to multiply together to make?
2 times 1.
Good, you'd be looking together to make the 2, right? And what numbers would you look to add together to make?
3.
The 3, right? Okay. Now when you come over here, it's the same kind of principle. In fact, I've made you on the right kind of lines here. Except you're not looking for numbers that multiply together to make that last number anymore. You're looking for numbers that multiply together to make 2 times the 10. Yeah? So you're looking for numbers that multiply together to make
20.
Instead of 10 now. Is that clear? That's the only difference with this. Okay? But you're still looking for numbers that add together to make this 9. Okay, so let's think about this. What numbers multiply together to make 20 and add together to make 9?
5.
5 and 4. 5 and 4 definitely works. Okay. Now the question is, where do we put this 5 and this 4? Well, really simple. You just break up this 9x into 5x, in fact positive 5x, and positive 4x. Okay? Positive 5x and positive 4x. Everything else stays the same. So you've still got your 2x squared at the front, and you've still got your plus 10 at the end. Is that okay? That's the hardest bit. That's the hardest bit done. Okay? And all you do is you just split this down the centre, and you go, okay, I can totally factorise this half. So if I was going to factorise 2x squared plus 5x, what would I pull out? Just an x, right? And what would go inside the brackets?
5 plus x. 5 plus x.
2x plus 5x.
2x.
Now whatever happens, I must have exactly the same bracket over here. I must have a 2x plus 5. So actually the question becomes slightly easier. It's like, what number goes here, which when I multiply it out, gives me 4x plus 10? 2. It's 2, right? And it's got to be a positive 2. Is that clear? Okay. And I'm going, okay, well I see a 2x plus 5 in both of these terms, so I could just factorise it out. Which would leave me with an x plus 2. Is that okay? Good. So this is how you could deal with this, for example. Okay? And you go, hang on a minute, why are we doing something completely different here to what we were doing over here? Well, we're not. We're doing exactly the same thing. In fact, if I show you this exact same method on this one, so x squared plus 3x plus 2, you'd be going, okay, I'm looking for 2 numbers that multiply together to make what? 2. Yeah, so just think about this as 1 times 2, or 2. And we just add together to make this middle number, 3. You go, I know numbers that multiply together to make 2 and add together to make 3. It would be 2 and 1, right? So I break that up into positive 2x and positive 1x, or positive x. But everything else stays the same. So x squared and plus 2. And then I go, okay, I split it down the centre. And I look at that side. I factorise that. What could I factorise out? X. Inside the brackets I'll be left with x plus 2. whatever happens, that thing must be the same over here. What has to go here? There has to be a number that goes here. What goes here? Just one, positive one. And if I factorise an x plus 2 from both of these terms, I'm left with x plus 2, x plus 1. So it still works. So if you only want to remember one method for factorising quadratics, this is the one to go for. It's just, over here, you could have jumped straight from here to here.